I am excited to share with you this machine learning image classification project that can make prediction and provide accuracy score. For the purpose of this project, 5 notable personalities were selected. We have Beyoncé, Kamala Harris, Sharapova, Lionel Messi, and Putin. Now let's try and make predictions using images of these personalities that the model was not trained on. Let's start with Beyoncé. This is an image of Beyoncé, and I'm going to classify it now as if the model will predict. So the model is able to predict it. We can see that Beyoncé has a probability score of almost 90%. Now let's look at Kamala Harris. We can see that the model is able to predict Kamala Harris as well. The model is saying that, okay, I'm 75% certain that this is Kamala Harris. And you can see the score for other personalities. Now let's try and see if the model will be able to predict Sharapova. So by uploading the image of Sharapova in the drop zone, we can see that the model is able to predict Sharapova correctly as well, giving accuracy score of 75%. So the model is 75% certain that this is Sharapova. Now let's go to the next personality, which is Lionel Messi. This is an image of Lionel Messi that the model has never seen. Now let's see if it will be able to predict correctly. Wow, that's good. You can see that the model is able to predict correctly as well, that this is Lionel Messi with accuracy score of 89%. So the model is 89% certain that this is Messi. Now let's look at Vladimir Putin, if the model will be able to predict it. Then after uploading the image of Vladimir Putin, we can see that the model is able to predict correctly as well with 99% probability score. The model is telling us that I'm very certain that this is Vladimir Putin. 99% certain that this is Vladimir Putin. So far the model has performed very well with high accuracy on the personalities that we have for this project. Now let's see how the model will behave on an image that is not among the personalities that we have. So for this purpose, I'm going to upload the image of Dwayne Johnson, The Rock, and let's see if the model will be able to predict correctly. Okay, the model is telling us that Ops unable to detect face and eyes image classification field. So because Dwayne Johnson is not part of the personalities selected for this project, so the model is telling us that no, I've not seen this face before. After seeing the good performance of the model, now let's look into the process and tools used for this project. First, I used Flask to download multiple images of each personality from Google. After that, I used OpenCV to resize and normalize all the images. This is to ensure they had consistent dimensions and of high quality. In order to build the model, different models and parameters were considered, and GridSearchCV API was used for hyperparameter tuning and to identify the best model and parameters. So for the web interface, the backend aspect of the web interface, I made use of Python Flask server to connect the model and the web platform. So this is the script of the model that is running the model, accepting the images, processing it, and also giving feedback to the server, and feedback from the server is given to the web interface. Then I made use of NGINX as the web server that connects directly to the Python Flask server. So with this setup and the connectivity, it allows the whole process to run seamlessly, from uploading the image to predicting the personality, as you have seen. Then for the web interface, the user interface of the web platform, I made use of HTML, CSS, and JavaScript. So these are the trinity of web development. This is the HTML script for the web interface. Here is the CSS script that enables the simplicity and design of the web interface. And here is the JavaScript that enables the interactiveness and functionality of the web platform. The application of image classification is beyond recognizing or identifying famous personalities. It can be used in different industries Like in recycling industry, it can be used in sorting and classifying waste like paper, plastic, metals, and so on. So this is more efficient than mechanical or manual sorting of waste. Then in the healthcare, it can help medical personnel in diagnosing diseases from medical images like x-rays. In security, it can be embedded in surveillance systems to detect suspicious activities and to recognize faces. It can also be used in agriculture. It can be used in agriculture to detect diseases and pests early, which enable farmers to take necessary action. It can be used in retail and so many other industries. That's it on this project. If you have questions or suggestions, please let me know. Special thanks to Code Basics for the resources provided.